Hi there, we are Algaesthetics, and we've been working to create a biodegradable prosthetic to combat the high rates of prosthetic abandonment and user dissatisfaction. Based on our research, 300,000 prosthetics are discarded every year, and as they are typically made of hard plastics, their inability to decompose contributes to high volumes of medical waste. We have been continuously inspired by the quote, "I want to take off my prosthetic arm and know that it is mine from across the room." We hope to facilitate better experiences between prosthetic and users. To prove that our prosthetic is environmentally liable, our technical metrics will compare biodegradation timelines between algae plastics and silicone plastics. Silicone can take anywhere from 50 to 100 years to decompose. However, the algae plastic alternative we have been using can biodegrade in 12 weeks when exposed to right conditions. When used under normal conditions, flip-flops made by the Center for Renewable Materials at UCSD have lasted for up to 3 years. We want our prosthetic to last this long, if not longer. To gauge our social impact, we will plan to include customizability metrics to gauge user satisfaction. We have been inspired by companies like the Alternative Limb Project, which customize prosthetics based on their specific users' personalities and interests. We aspire to design on an individual basis with our users. However, our first steps will include customizable 3D printed designs onto the cover of our prosthetic and a range of colors with eco-friendly dyes.
Our prototype will be made out of mainly two materials. One of them is thermoset urethane, which is a plastic foam. Multiple liquids are poured together to react and create a foam-like plastic. Different solutions reacting together make the bubbles that make the material, which then expands and hardens. The other material is alginol. We plan to create a customizable algae-based bioplastic for the cover of our prosthetic with alginol. Agar bioplastic is a vinyl-like material made from marine algae that can be laser engraved, dyed, and changes color when exposed to different temperatures, depending on what materials are applied to it. Alginol is a patented bioplastic that is made of accessible food-grade ingredients and based on open-source recipes from Materiome that were altered to give the material more flexibility and strength.
We made a small sample of alginol using water, agar, and glycerin. The process included mixing 2 grams of agar, 3 grams of glycerin, and 50 milliliters of water. The mixture was then boiled at 90 degrees Celsius on a hot plate to activate the agar. It was then immediately poured onto a small styrofoam container and slightly covered with a piece of paper. The mixture was left to dry for a week in the lab room. After a week, we noticed the alginol began molding. We did not sterilize the container nor fully cover it before leaving it to dry, which could have created the mold. In our second trial, we tripled the recipe to fit our mold with greater surface area, sanitized the mold with alcohol-based cleaning product, and sealed the mold tightly with saran wrap to prevent contamination. We left the solution in a drawer over the week and discovered the next week that our solution was still liquid. It had also molded once again. With more time, we would experiment with keeping the solution to dry in different kinds of environments.
For trial 2, we used our teammate's arm to create the mold. Her arm was covered in about 1/4 inch of clay slabs from the elbow to fingertips. We scored 3 sections to remove the clay mold from the arm once it had dried for about an hour. We attempted to create more defined individual fingers on the inside of the mold by placing pieces of clay in between her fingers. Unfortunately, we were not entirely successful since some of the pieces came off with the hand as the clay was still wet. Since we used our teammate's arm for the mold, we could not leave the clay on for a longer period of time to dry. While waiting for the algae plastic, we worked with a placement holder plastic foam. With proper lab attire, we have poured equal ratios of chemicals into 2 separate tubes from the inside of the fume hood. Here we added a couple drops of food coloring to both tubes to customize colors. After coating the mold in silicone spray to help release the solidified foam from the container, we poured both chemicals into the mold and immediately blended the mixture using a powerful drill with a special attachment. After the reaction begins, immediately we removed the drill and its attachment from the mold to submerge in water to remove most of the toxic mixture. Once we had done a trial round, we repeated this process and poured the mixed solution into our clay arm mold. Once the foam had stopped growing, we let the mold and foam sit for about an hour before starting to peel the clay off. The result was not very successful as the plastic stuck to the clay and was very difficult to remove. So we decided to try another mold for the plastic.
We decided to try alginate mold of an arm instead of clay to see if the material would hold up any better. We mixed 1 part Algasafe powder with 4 parts water by weight and mixed the solution with first a drill mixer, then decided that mixing it manually was the best approach. Once mixed, one of our team members inserted her arm into the solution and after a wait time of 12 minutes was able to pull her arm out with relative ease. We repeated the mixture of the solution to make our plastic foam and poured the solution into our alginate mold. The reaction took place and we left the mold to dry for 2 days. The alginate was much easier to remove from the plastic than the clay had been, and our foam had taken the shape of a hand. We decided that this was our best approach to make a prototype for our prosthetic.
We intend to be mindful of the specific expectations and characteristics that users associate with our product, especially the similar associations that users connected to the bio-based products in the study. We hope that users will see the same environmental benefits, trust the biodegradability of our prosthetic, and believe that our environmental intentions are true.
A vast majority of prosthetic users speak on the importance of being heard in regards to their goals, wants, and needs. We've reached out to the Sacramento amputee group to include prosthetic users in our design process. However, we are still awaiting user testimonies at the time of this video. Inclusivity and fitting into their community is a repeated need from prosthetic communities, and we strive to make users feel comfortable with their bodies through Algaesthetic products. Therefore, the customizability of our product is extremely important to our social factors. We want to provide colors and designs that are also made from biodegradable materials to facilitate a positive connection between users and prosthetics. It is important to the success of our product that we encourage diversity and expectations of beauty. We are in an age of social reckoning about beauty standards and who sets them. We want our prosthetic users and other disabled communities to feel beautiful and accepted in major media by providing a platform for them to feel empowered. Designing with prosthetic users rather than for them is an important step to challenging the beauty standards set by able-bodied communities. Our team aims to bring the world of design for medical technologies as a solution to current-day social stigmas.
We understand that there is a risk associated with any new invention. To prevent any safety issues, we shall make sure that the prosthetic is properly fitted, and we shall urge the client to limit the use of specific activities, for example, submerging in water for excessively long periods of time. Since users could customize the outside of the prosthetic to spread negative messages or symbols, we shall have quality checks and have the users be legally bound to not use the prosthetic for any violence or abuse.
Our prototypes leave us optimistic for our algae-based prosthetic. While we realize our prototype is nowhere near finalized, the hands-on experimentation has been invaluable to our understanding of the balance between prosthetic function versus prosthetic comfortability. We hope to be more involved with the prosthetic community as our product design continues.
There's always room for improvement, so we would move forward with our successful alginate mold if given more time to make a complete mold of a whole human arm. We'd also use the algae-based plastics from UCSD and test how it reacts differently than the placeholder plastic that we've been using. We would also do more experiments with our alginate covering to figure out the best conditions for our solution to dry properly, and then follow that with making the solution with different dyes and designs.